Hey guys, it's Carrie, and in this video we're doing homework number 2. So, solve the following equation for all values of x. Make sure your answer is in simplest radical form. So to solve this problem, it's set up perfectly for us. We're going to take the square root on both sides to cancel the square, and we get x is equal to, and I'm going to fast forward a little bit. We know we're going to add 3 on both sides, plus or minus square root of 28. So if you stopped here, you got it wrong. Well, you didn't really get it wrong. You got maybe 2 out of 3 points. And the reason why is on the regents, they're going to want to make sure that you put this in simplest radical form. And 28 can actually be broken down. So we break 28 into 2 and 14, 14 into 2 and 7, and we rewrite our answer as 3 plus or minus the square root of 2 times 2 is 2 squared times 7. Now it's beneficial to write it this way because square roots and squares cancel, giving us x equals 3 plus or minus that 2, no longer with the square because that canceled, no longer in the square root, because that canceled, square root 7. Solve the following equation for all values of x. You guys got this one. I'm going to do the tougher one down here, problem number 3. Solve the following equation for all values of x. If necessary, make sure your answer is in simplest radical form. So we have a 4 here, which makes the problem a little tougher. But if we divide through by 4 on both sides, we're in pretty good shape. X squared plus 10x minus 4 equals 0 over 4 is 0 itself. Now this actually looks a lot like the problem above. So if you did this one, number 2, I know you can do number 3 also. So the whole idea with completing the square is if we had a different number here, things would work out really well. So why don't we add 4 on both sides to get rid of that number? That gives us x squared plus 10x. Kind of missing that number there and 4. I want to put a number there, so think ahead. I know I want to end up with the same thing, so I could rewrite it as, that thing squared equals something. So this is going to have to be the same factor here and here. They got to add to 10. So 5 and 5 make 10. 5 times 5 is plus 25. But we can't just add it here. If we want 25 there, we need to add 25 on both sides of the equation. So this equals 29. This equals 29. Then we square root. Oh, wait. I'll pause for a second. Now that we're here, this equation is substantially better because it looks exactly like our first equation, which we know how to solve because we only have one x instead of the 2x values that we started with. So solving this for x, we get x is equal to negative 5 plus or minus the square root of 29. And if you don't see that all in one step, don't worry about it. Take your time. You can get it right. So for number 4 and number 5, let's see. I don't know that I want to do both of these. Yeah, let me just do number 4. And yeah, you guys can figure out the rest. So y equals x squared plus 4x minus 12. So we go over to Desmos. That's not Desmos, that's Feedly. Desmos, and we do y equals x squared plus 4x minus 12. I think I got the right equation there. Yep. All right, now we're looking for a bunch of stuff. So the x-intercepts, y-intercepts, and vertex. Let's get those all at once. X-intercepts, y-intercept, vertex. So now the hard part for me to remember is to remember this as I switch over to the app where I take notes. So it looks like the x-intercepts were negative 6, 0, 2, 0. The y-intercept was 0, negative 12. The vertex was, oops, don't remember that one. Negative 2, negative 16. And this actually allows us to plot a rough sketch of the graph. And I realize I don't have enough tick marks, so I'm just going to improvise. Back 2, down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Sorry about that. So we'll put our vertex there. We've got our y-intercept at negative 12. Sorry about that. You could have rescaled your axes, I guess, to make things better. 2, 0, and negative 6, 0. And now we've got our parabola going through here and through here. Perfectly symmetric across the vertex. All right. So next up, we're done with the sketch. The minimum value of the function is going to be at that vertex. The coordinates were negative 2, negative 16. But when you think about minimum, that's a vertical minimum. And the vertical minimum is specified by negative 16. So negative 16 is the minimum value of the function. The domain is all of the x values that can be plugged into this function. So if you think about this function, you could plug in any x value you want. You could plug in 100, and you're going to get a really large number. But the math is going to work out. There's not going to be any division by 0 or crazy square roots. You could plug in 1,000,000 or 1,000,000,000, whatever number you wanted, you could plug in, and you would get a y value for that. So what this means to me is that the domain of this function, let me change colors because it's a little hard to see. The domain of this function is x can be any number. And a way that you could write that is, if x can be any number, then x is any number between -infinity and infinity, if you like to write that maybe more mathematically looking. The range of this function is going to be concerned about the y values. So if we think about the y values, let me see if this works. If we think about the y values, we want to start by thinking about our equation for y. So we've got our inequality for y. So we've got an inequality like this. There's going to be some minimum y value and some maximum y value. And so we think with starting about the minimum, we can imagine starting all the way down here at -1 billion. And there's no y values there. But if you keep raising it, the lowest y value that we actually hit is -16. Now, if we think about taking that line, and I can't move it anymore because I put it where there's other pencil marks. You think about taking that line, and you're like, where's the maximum y value? Is it here? No, it goes past that. Is it here? No, it goes past that. Is it here? No, these arrows mean it goes past that. There is no maximum y value, so we'll say that it's capped off at infinity. And so the range of our function is y, let me take it in 2 steps. -16 is less than, but actually less than or equal to would have been a more appropriate choice because at the vertex it actually hits -16. -16 is less than or equal to y. Or, if you flip it around, y is any value that's bigger than -16. And graphically that makes sense because any value bigger than -16 is going to get hit. Using Desmos, graph the parabola whose equation is y equals, oh man, the same one. That's the same one. That's so crazy. Wow, who wrote this problem? That was me also. So this one has to do with increasing and decreasing, and we'll talk more about that tomorrow. But thinking about a parabola, increasing and decreasing is going to be at some x line. On this side, it looks like it's increasing. On this side, it looks like it's decreasing, because as you read from left to right, it's going downwards. And as you read from left to right here, it's going upwards. So when you answer this question with these intervals of increasing or decreasing, think about where that changes. And maybe that helps you solve it. Anyway, I'll see you guys in class on Tuesday next week. Enjoy your long weekends. Bye.